Good morning. Today we are working on our first objective in our math binder. So you'll notice we find CO1 up on the left corner. Some days we'll be working on POs. Similar to last year when you did power standards, and it was the important, you have to master these things in math class. That's what power objectives are. The power objectives are the ones on our test that we have to retake until we master them, until we pass them. Course objectives, the COs, are important because it's math and math builds on itself, but we only have to master 80% of them by the end of the year. So if you come to a CO and it's the only one that you don't have passed, it's okay. You don't have to retake it, but I strongly encourage everybody to retake all of their objectives so we make sure that we have that strong math confidence. But you only have to have 80% mastered. So what I found over the last few years is people do all their retakes, and then we get to the spring and they go, it's our second to the last test. I had 100% of my objectives have been mastered. I know if I don't retake these two that I didn't pass on this test, my grade is still good, I'm doing fine in the class. It gives us that cushion in the springtime where we're not feeling that crunched up, ooh, I have to retake these. Okay, so the COs, especially in the fall, we definitely want to be retaking them, making sure we're understanding our math and we're doing well. So today we are doing CO1. I can identify whole numbers, integers, and rational numbers. So that means we need to know what those definitions are. What is a whole number? What is an integer? What is a rational number? So with a number system as large as ours that we have, it's helpful to have it broken down into categories. So it's types of numbers. Here are a few of them with the most specific category listed first. So the narrowest one. So there's not as many that fit into this. So a whole number is a positive number not a decimal or fraction. So a whole number has to be positive, no negatives. If you see that negative sign, you know it's not a whole number. Cannot be a decimal or a fraction. So if you see a decimal in a 10th place, not a whole number. If you see it listed as a fraction, you have to be careful. When would a fraction be a whole number? What do you think, Natalie?
If the numerator is more than the denominator.
That makes it improper. Doesn't make it a whole number. What do you think, Beckett?
If the numerator and the denominator are like the same.
Well, if they're the same, it equals 1. So if we have 4 over 4, that would equal 1. So that would be a whole number. When else might a fraction be a whole number? David?
When the numerator is double the denominator.
When that numerator doesn't have to just be doubled, well, let's say we have 15 thirds. Can I simplify that? Yeah, I can simplify it down to a whole number. So it's super important when we're working on this objective, when we get to a fraction, can I simplify it? Because sometimes they give us a fraction that really is a whole number. But it's not every time that numerator is bigger than the denominator, because that's just improper. We can't simplify that down anymore. It would have to be one that you can simplify down to the whole number. All right, so that's our first one, whole numbers. Being careful with the fractions, making sure that we're checking if we can simplify it. An integer is a positive or negative number but still not a decimal or fraction. Again, making sure that those fractions are simplified down. So a whole number is only positive, not a decimal or fraction. An integer is positive or negative, but not a decimal or fraction. Then we have a rational number. A rational number, so remember we were the most specific at top, so now we're getting bigger and bigger. A lot more numbers are going to be included. So the rational number is positive or negative. It can be a fraction or decimal, but the decimal must end or repeat. So if we had 1.5, 1.5, that ends. That would be a rational number. It ends. That decimal has an ending point. Or it repeats. 1.5555555. Sometimes we'll see that written as 1.5 with a line above it. Let me write that a little lower so I don't blend in. So if you see 1.5, that line above the 5 means that 5 is repeating. So when you see the line above a decimal, it just means it keeps on repeating forever. If it ends or repeats, it is a rational number. A number that doesn't end, a decimal that does not end, like pi. 3.14, I always know is the first beginning of pi. But pi goes on and on and on and on and on and on. I've had some students try to memorize, oh my gosh, I had somebody a couple of years ago that went out to like 75 decimal places memorizing pi. They knew a song that helped them learn all the numbers in pi. It goes on and on. It cannot be a rational number if it keeps going on and on and on. So pi is not a rational number. Okay. So those are the three main groups. Then we have a fourth category, one that doesn't fit into any three of the above. So it's not like these, it's irrational. An irrational number is a decimal that does not end or repeat. We know if it ends or repeats, it's rational. So if it doesn't end, like pi, that would be an irrational number. Any questions on any of those? So that's just the definitions. We're going to see how we're going to work with these numbers, with these categories. So here's a way you can visualize how the four categories are related. Our whole number is the smallest because it is only those positive numbers, no decimals, no fractions. So a number like 5 or 9 or 13, those would be whole numbers. And then we have integers. Integers is a whole number an integer? If it's a whole number, can it also be an integer? Yeah, that's why it's inside that box of integers. So a whole number is also an integer, that's a given. But it could also be those negative numbers. Maybe negative 20, negative 8, negative 12. Those are also integers. So integers are those negative numbers and the positive numbers. Then we have rational numbers, the big box on the outside. Can a whole number be a rational number? Yeah, it's a positive number. Can it be an integer? Yeah, integers are negative numbers. So an integer is inside that rational numbers box. It could also be a fraction. It could be a decimal that repeats itself. It could be a decimal that ends. If I can get my pen to work. It could be a negative fraction. Those are all rational numbers. Can 3.21 repeating be an integer? That's outside of the integer box. So remember, the integer is only positive, negative numbers. That's why we had to put the decimal place outside of it. So if it's a whole number, it's automatically an integer and a rational number. So think about four-sided figures. Think about a rectangle. Is a square a rectangle? Yeah. Square is a type of rectangle, but a rectangle is not a type of square, right? Because a square is a special rectangle where all four sides are the same size. So if it's a whole number, it's automatically an integer and a rational number. If it's an integer, it's automatically a rational number. Only whole numbers are whole numbers. Nothing else can be a whole number, just those whole numbers. Because there's no other boxes inside that whole number. Does that make sense? Irrational numbers, something like pi, the square root of 12, that's something that we haven't learned yet, but we will be learning. It is a decimal that goes on and on and on and on. If I give us a decimal like this, and then I do dot, 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 that dot, dot, dot means it goes on and on and on. So irrational numbers are those decimals that do not end. Another way to think about it is you are a sixth grader. That would be like a whole number. You're a part of the middle school, 6, 7, and 8. So that would be like the integer, which is a part of St. Vincent de Paul, which is our school, which would be a rational number. So could a kindergartner be a sixth grader? No. They're a part of St. Vincent de Paul School, but they're not a sixth grader. Right? So those whole numbers, that's you being a sixth grader in the middle school in St. Vincent de Paul. So an irrational number would be Gianna, who's at school in Blaine. Not a part of St. Vincent de Paul. Something totally different. Irrational numbers. They don't fit in here at all. They don't fit in any of those categories. The next thing on your page says simplify a number before making a final determination about its category. That's what I was doing over here. If we can simplify it down to a whole number, then it's a whole number, right? So look at those fractions. Always, always look. Is it as simple as it gets? So it can't be a whole number? Or can we simplify it down to be a whole number? Let me erase this and scroll up. So always simplify those fractions before you say what category it's in. Because it could change if it's an integer or a whole number. Classify each number as whole integer, rational, or irrational. List all categories that it belongs to. So let's look at what that means. 65, is 65 a whole number? Yeah, so I'm gonna put a W under it. If it's a whole number, is it an integer? Yeah. Is it rational?
Yes.
Is it irrational? No. Negative 12.7, is it a whole number? No, because there's a decimal, and it's negative. Is it an integer? Ooh, I see some saying yes, some saying no. Show me your thumbs, what do you think? Yes, it's an integer. No, it is not an integer. Natalie, why do you think it's an integer?
Because an integer is a positive or negative number. So,
What's the second part of that line?
not a decimal fraction.
Is this a decimal?
No. Yes.
It is a decimal. So you're right that it's negative could be an integer, but it is a decimal. So it cannot be an integer because there's that decimal there. Can it be a rational number? Yes, because rational numbers can be decimals that end. 12.7, it ends at the 10th place. 7/10 and we're done. So it is rational. -1, is it a whole number? No, because it's negative. Is it an integer?
Yes.
Yes. If it's an integer, is it rational?
Yes.
Yes. Remember, when the line is above, it means that it repeats. When it's dot, 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 it goes on forever. You're gonna finish this page on your own. We're not gonna do it at this moment because we wanna look at our second page so we can get the directions for the second page. Answer each question. Some questions may be not possible. Okay, so then that's going to be your answer, not possible. So let's look at that first one. What is a rational number that is not an integer? You're going to give an example. Okay, so you're going to want to look back at your definitions. A rational number, but it's not an integer. What would be an example of that? Michael?
1.1.
1.1. Because a rational number is positive or negative, and it can be a decimal or a fraction. Decimal that ends or repeats. But an integer cannot be a decimal or a fraction. So that works. What would be another example? David?
0.25.
What might be another example? Robbie?
10.9.
Who can give me a totally different kind of answer? Negative numbers, yeah. What about, did I put -7/5? Yeah. Because it could be a fraction, could be a decimal, could be a decimal that repeats. So I could say 6.53 with that 3 repeating. Those are all examples. You only have to give one. But you have to make sure that it fits in that category. What is a whole number that is not rational? What would be an example of a whole number that is not rational? Harper?
It's not possible.
You are absolutely correct. Whole numbers will always be an integer and rational. So we cannot be a whole number and not be rational. You're going to answer the rest of the questions. Let's look at our next section in the middle. Determine whether the statement is always, sometimes, or never true. So you're just gonna have to decide, looking at those definitions. An integer is a whole number. Is that always, sometimes, or never? What do you think, Christina? So Christina thinks never. Can anybody give me an example that would fit? Or an example that proves it wrong? An integer is a whole number. That will never, ever happen. Is that true? Graham?
No.
Give me an example.
6.
Positive 6, is that a whole number? It is, it's positive, not a fraction, not a decimal. Is it an integer? It is an integer. Integers are positive or negative numbers that are not fractions or decimals. So if 6 works, does negative 6 work?
No.
No, because a negative number cannot be a whole number. So it works for the 6, but it does not work for negative 6, so we would say sometimes. Because this was a yes, but this was a no. So sometimes an integer can be a whole number. Sometimes it's not. Okay. So always look to see, is there a number that works? Is there a number that doesn't work? If you can't find a number that doesn't work, then it would be always. If you can't find a number that does work, it would be never. Okay? That makes sense? All right. And on the bottom, you and your parents are gathered around the TV one night watching the Discovery Channel when suddenly you lose your satellite signal. Not being used to interacting socially with each other, things get a bit awkward. What do? Can't watch TV. Then you get an idea for a game. Each of you will take turns saying a number from one of the categories listed above. So somebody can only say rational numbers. You can only say rational numbers. Your mom can only say integers. And your dad can only say whole numbers. The winner is the person who can say numbers from their category the longest. Assuming you are each familiar with the categories, who will win and why? So you're going to answer that question. You're going to think it through. Who will be the winner of the game? And why would they be the winner? So you're going to write that answer on the bottom of the page. So, are there any questions on today's assignment? David?
Do we do the third one that says like use a calculator?
Oh, I missed that one. Thank you. Totally missed this other one. Use a calculator to evaluate each radical and classify it as rational or irrational. So, get out your calculators. I'm still recording. So our first number is 225. What is the second number? Square root of what? Is that 83? Okay, the reason I'm asking is I'm going to have to go off of this and go onto here. So let's look at how we do the square roots on our calculator. Have y'all done square roots on calculators? Okay. Yay, we get to use these fun new calculators. So our first number was 225, and that little symbol above it is the square root symbol. So we're going to find that same symbol on our calculator. So if we look right here, if you have the same calculator as me, you can see x squared on the main plate here. You can see that square root symbol. Okay, it's a little bit lighter, but it's right there above the x squared. To get to that, we do the second button, and then we press it. That means we want the square root. Then we type in our number, 225, and we press equals. What does it mean when we square a number? Luke?
Multiply it by 2.
Multiply it not by 2. David?
By itself.
By itself. So you see that number 2 times. So we would see, let me just move this out. When we square a number, we would see if we have 5 squared, that would be the same as saying 5 times 5, because there's 2 numbers, that's why there's the 2 there. So what is 5 times 5? That's 25. So the square root is the opposite. What number times itself equals 25?
5.
That would be 5. So the square root of 25 is just 5. Just like that 225 that we did on our calculator, its square root is 15. If you do 15 times 15, it equals 225. Does that make sense? Okay, so square and square roots are opposite. Multiplying and dividing are opposites. The square and the square root are opposites. So if we look at the square root of 225 is 15, what is it asking us? It's asking us, is it rational or irrational? What do you think, Beckett?
Rational.
Rational, because it's a whole number, it's 15. So you would write rational for the square root of 225. Let's try the next one. So again, I go to the second button. I go to where that square root symbol is, and then it said 83. Then I press equals. Ooh, look at that number. 9.1104335779. It doesn't do ... because it's a calculator, but when you get the whole entire screen like that filled up, you know it goes on and on and on, and there's no repeats. So would that be rational or irrational? Irrational. So there's a decimal, so we know it can't be, well, no, rational numbers can be, but this one goes on and on and on. Now, every year I have people who say, well, Miss Gambino, why is there some spaces? When we look at our screen, okay. When we look at the screen, it's still a little crooked, it looks like there's a big space between the ones here, and there's no space between the 1 and the 0. The reason for that is our calculator has that whole amount available in case the number needs it. A 1 only needs that one side of that box. So that's all that lights up. That's all that it means when there's a space in the calculator. No different than between the 1 and the 0, between the 1 and the 1. All it means is on the calculator, it digitally didn't need the space. So it's not telling us any other information. So this is 9.1104335779. The space in the ones means nothing. Okay? Christina.
You have to write down the numbers too.
Does the directions ask us to write down the numbers? So if we look at the directions, evaluate each radical. When we evaluate, we do the math. When it says evaluate, you just do the math. So we're going to find the square root of each of these radicals and classify it as rational or irrational. So does it say write down the answer? No. It says put rational or irrational. So you decide if it's rational or irrational. So you just need to put all of those in. Sometimes we look at a number and we might not even have to put it in the calculator because we know, oh, it's this number times itself is the answer. I don't even have to put it in my calculator. I already know because I know my multiplication facts. Sometimes those multiplication facts, we don't go up high enough in what we know. So we might not know 15 times 15 is 225. But there's a number on here that we might know just off the top of our head is a rational number. Okay, so if you know your multiplication facts, you know which one I'm talking about. All right, any other questions on today's assignment? So some of us may get this done in class, the first page and the second page, both pages. Some of us might not get it done before it's time for us to switch. Then it's homework. I do not want to see anybody rushing through trying to get it finished so we don't have homework. That's not how we learn. Okay, if you're just rushing through, you're going to make lots of mistakes and you're not going to understand. And if we get in bad habits now on day one, we're setting us up to have a really rough spring. I had some friends last year that got into really bad habits, and I kept warning them, stop doing this. You're going to hit stuff that's going to be more challenging, and you are not going to do well. And we struggled in the spring, and we had to stay after school for extra help, and we had to do a lot of retakes. Make the good habits now. If you have homework, bring it home and work on it. Don't rush through. Okay? So I'm gonna end our recording now. If you are watching this from home, I hope you are well, and I hope to see you soon. Have a wonderful day. Don't forget to like and subscribe.